A template type is a special type in C++ that can take on different types whenever the type is initialized. For example, the standard vector is a template type. What that means is in the standard vector, we can have a vector of characters, for example, the word Illinois, a vector of integers, for example, the first few prime numbers, or even a vector of UIUC cubes, our custom data type. All of these things represent an array of objects in memory, and it's done through a standard single library called the vector. The standard vector, or ST vector, is part of the standard template library we discussed earlier, and it provides the functionality of a dynamically growing array with a templated type. So there's 5 key ideas of how we're going to use this vector. The first is we're going to include the vector in our program by using #include vector. And that's going to add the ability for us to use the standard vector into that source code file. We initialize a vector by saying std::vector, and we give it the templated type inside of these alligator braces. For example, on the previous slide, we saw inside these alligator braces was character, was int, and was UIUC cube. Once we have a vector initialized, there's 3 functions that we're going to run on this vector. The first is to run the function pushback, and that adds an element to the back of the array. Our syntax would be something like v.pushback of 4. This pushes back the number 4 onto the vector. The second function is the array operator bracket. So for example, we might want to access the first element in our vector. We would say v at 0, since v was the declared vector, and we want to access element 0. This v at 0 is going to retrieve us the 0th element in the vector, so that's going to be the thing that we just added if we've only added 1 element to the vector. The last thing we can do is we can say v.size, which asks the vector what its size is. As we mentioned earlier, when initializing a templated type, the template goes inside of the alligator brackets at the end of the name. So for example, the name of the object we're initializing is a standard vector, and we use these alligator brackets at the end. So this is a standard vector of characters. We can go ahead and see this in source code. So here's a simple program that just uses both the vector and the IOStream library. We've included both of these libraries. And then here on line 11, we have our main. And on line 12, we initialize a new vector that's going to store integers. So we're creating a vector. This vector stores integers. And because vectors are dynamically growing arrays, if it runs out of space, it's going to make it larger. I'm going to draw it exactly how large it needs, but we're not exactly sure what the capacity of that vector is. And next week, we're going to actually explore some detailed analysis to understand what the optimal size of a vector might be. Here, we're going to push 2 to the end of the vector. So here, we're adding 2 to the vector. 3, we're pushing 3 to the back of the vector. And 5 to the back of the vector here. And then on line 17, we're going to see out v at 0. So we're going to look at our vector and look at what's in index 0 and print that to the screen. So in index 0, we're going to see 2 get printed out. Index 1 is here containing the element 3. And index 2 contains the element 5 and 5. So when we run this program, we expect our output on our screen to be 2, 3, 5. Let's head over to the console and see what happens. I'm going to move into the CPP vector directory and then move into the example1 directory and run make to build this program. Then run /main to run it. And here we see the output of 2, 3, 5, exactly what we expected. Let's go and look at a second example. Here's the source code for example 2. We see the same thing, that we're including vector and IOStream as the 2 libraries we're going to use. So what we know is we're probably going to be using a vector to store some data, and we're going to use cout to output data to the console from the IOStream library. Here on line 11, we find our main. Line 12, we initialize a new vector. This vector is going to contain a lot of objects because we have a for loop here that loops from 0 to 100, and we're going to push back the square of whatever I is. So the first time this for loop runs, I is going to be 0, and I'm going to push in 0 times 0 to the vector. So the first element in the vector is going to be 0. Second time the loop runs, I equals 1. I'm going to push in 1 times 1 to the vector. So the second element in the vector is 1. Third time we run through the loop, I is equal to 2. element in the vector is 2 times 2, so 4 goes into the vector here. When I is equal to 3, we're going to put 3 times 3, or I times I, into the vector. That's going to put 9 into the vector, then 16, then 25, and so on. So each element of the vector up until the 99th index is going to contain the square of its index. Note that here is element index 0 that contains element 0. Here's index 1 that contains 1 squared, or 1. Here's element index 2 that contains 2 squared, or 4, and so forth. Now on line 17, we can predict what's going to happen when we see out v of 12. V of 12 is going to look at index 12. We know that the value contained in v of 12 is going to be the square of its index. So looking at 12 times 12, that's going to be equal to 144. So we expect the output of v of 12 to be 144 because v of 12 is going to be placed into the vector by pushing it back when I is equal to 12. Let's go ahead and see if this matches up when we run our code. Here in the console, moving out of the example1 directory, moving into the example2 directory, running make, and /main. And here we see the output is indeed 144. So what you've seen here is we now have an ability to create an array-like structure inside C++ called a vector. The vector is slightly different than an array that you may be familiar with in the sense that it grows dynamically. We don't care about its capacity because the capacity is going to grow and shrink as needed. In the next video, we're going to explore a program that makes use of vectors and all the things we know about to build something really awesome. So I'll see you there.